Hello friends, welcome to ECECASTS. Today we'll solve a question from circuit theory. This question appeared in GATE 2010. It is a 2 marks question. You can see a circuit in the problem. We need to calculate the power that is supplied by the voltage source, which is 10 volt. So in the first step, in order to calculate the power supply, we redraw the given circuit. So friends, this is the redrawn circuit. I will quickly explain how I get 3 plus I current from node A and 2 plus I current from node B. I have assumed that I ampere of current is flowing across this branch. When this I current crosses node A, it is added to 3 ampere of current flowing from this direction. So from node A, we get 3 plus I amount of current. This 3 plus I ampere of current, when crosses node B, 1 ampere of current flows in this right direction. So at node B, what we are left with is 3 plus I minus 1, which is 2 plus I ampere of current. That is how I get 2 plus I ampere of current in this node B. We go on to calculate how much of power was supplied by this 10 volt source. For your reference, I have marked these resistors as R1, R2, R3 and R4. So friends, we need to look at the outer loop of this circuit, that is the current which is flowing across node A, node B and node C. We need to frame KVL equations. For that, we need to know the voltage drop across R1, R2, R3 and R4. The voltage drop across R1 is equal to current flowing through R1 into the value of resistor. So that is equal to 3 plus I into 1. Similarly, voltage drop across R2 is equal to current into R2, which is again 3 plus I into 1. Now we move on to R3. So voltage drop across R3 is I2 into R3, which is, here by I2 I mean 2 plus I. 2 plus I into value of R3, which is again 1. Voltage drop across R4 similarly is I2 into R4, which is equal to 2 plus I into 1. So we get the individual voltage drop across each of these resistors. Now we frame the KVL equation. For the KVL equation, we know that the voltage drop across each of these resistors should be equal to the net supply of the circuit, which is 10 volt. The voltage drop across R1, which is 3 plus I into 1, plus across R2, which is 3 plus I, plus across R3, the voltage drop across R3, which is again 2 plus I, and that of R4 is again 2 plus I, equal to 10 volt. We simplify the equation, we get 6 plus 4, 10. So 10 plus 4I equal to 10. So I is equal to 0 amperes. So we get the value of I as 0 amperes. Now we are left with calculating with the power that is supplied by this 10 volt supply. So the total power supplied is equal to current into voltage. So that is equal to I into 10 volt. The value of I we had is equal to 0 amperes. So 0 into 10 volt, which is 0 watt. So friends, we move on to the slide which had the question and the options. So friends, from the 4 options, we see option A has a value of 0 watt. So our answer is option A. Thank you for watching the video at ECECASTS. Please subscribe for similar videos.